Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. So let's see this problem. We are given an array of elements and our task is to find whether elements in array is in sorted order or not. To solve this problem we have to keep two things in mind. We can sort array in two ways, either increasing order or decreasing order. But here we are specifically looking for only increasing order. And second thing is, same numbers or elements are allowed. Okay, it means if you have arrays, then it might be possible that two numbers are exactly same. Okay, to better understand this problem, let's see few examples. So here we have array of 5 elements, 1, 2, 3, 4, 5, and we can see that all the numbers are arranged in increasing order. So the output of this input is true. In next example, we have an array again of 5 elements, and here you can see that two numbers are exactly same. 2 and 2 are same, 3 and 3 are same, but these elements are arranged in increasing order. So that is why the output of this input is true. In case if we have only one element in array, the output is true by default. In next example, we have array like 2, 3, 4, 5, 1, and you can see that all these elements are sorted in ascending order except the one element. So it means this array is not sorted in ascending order. So the output of this input is false. So I hope now you understand this problem really well. So let's pause this video and think about a solution to solve this problem. Okay, by now I hope you would have written at least basic program to solve this problem. So let's first discuss the brute force approach to solve this problem. So here we have observations to be made. So let's say we have an sorted array. Here all the elements are in sorted order. So if you observe these elements, you can see that the first element is smallest and all the elements right to it are larger than this element. Okay, it means the 1 is the smallest element among all the elements and all the elements towards the right of it are larger. Okay, so based on this observation, the idea is really simple. We have to traverse entire array and pick one element at a time, and then for each number we have to find smallest element towards the right of it, and if we found any smallest number we simply return false. So this is the basic idea to solve this problem. So let's see the implementation of brute force approach. Here we have a function. This function is taking array as input. In the first line we are simply storing a length of array in variable L, and then we are running a loop from 0 to less than L, and inside of this loop we are again running a loop from I plus 1 to till less than equal to L. Okay, why I plus 1? Because first loop is just to pick one number and the second loop is to check all the numbers towards its right, and in inner loop we check if array of j is less than equal to array of I. It means we are looking for smaller number that is less than equal to array of I. If we found any number that is less than equal to array of I, then we immediately return false. And if we never went into this condition, then by the end of both the loops we return true. So let's quickly write in this code and see how it works. So let's say we have an array and the elements of this array is 2, 3 and 0. In first iteration our value of I is 0 and array of 0 is 2 because 2 is at the 0th index. Okay, so in first iteration again our inner loop begins, and in first iteration the value of j is 1 because 0 plus 1 is equal to 1, and at first position we have 3. So it checks if 3 is less than 2 or not. Okay, so this condition is false. So we continue to next iteration. In next iteration j becomes 2. So the number at second position is 0. It checks if 0 is less than 2 or not, and this time this is true. 0 is less than 2. So we immediately return false. So the output of this input array is going to be false. Okay, clear. So talking about the time complexity of this function, as we can see that we are running two loops, 0 to n. So first loop is running n times and second loop is also running n times. So in worst case, if you get array like this, then you have to traverse entire array. So what we do when we have nested loop, we simply multiply time taken by each loop, and that is n into n. So in worst case, the time taken by this function is going to be big of n square. But in best case, if you get array like this, where second element is the smallest element, then in the first iteration itself, you can figure out that the array is sorted or not. So in that case, the time complexity comes out to be theta of 1. But we generally care about worst case only. So overall time complexity of this function, we can say that big of n square. And what about space complexity? As we are not using any extra space other than few variables, it means we are using constant space to solve this problem. So the space complexity of this function is going to be theta of 1. Okay, great. But I think n square complexity belongs to the quadratic order of growth class. So can we do it better? So do we have any other way of solving this problem so that we can bring this time complexity to linear time? Think about it. So do one thing. Let's write down the sorted array on a piece of paper and try to observe that array. I hope you will get some idea to solve this problem in linear time. Okay, so now let's discuss the efficient approach to solve this problem. So the efficient approach of solving this problem is based on few observations. So let's say we have an array of elements A1, A2, A3, A4, A5, A6 and A7. So we assume that from A0 to A3 all elements are sorted. It means if these elements are sorted, then A3 is the largest element among all the elements, right? Because what happens when the array is sorted in increasing order, it means the last element is always going to be the largest element. So when we traverse this array from A0 to A3, then we come on to this element A4. So can we find that this element is at the right position? Let's see this example. Let's say we have elements like 1, 2, 3, 4, 5, 6, 7, 8. Until 4 that we know that these are already sorted. So it means 4 is the largest element among all the elements, right? Now when we come on 5, can we find that this element is at the right position? Yes, obviously, because if elements from 1 to 4 are sorted, it means 4 is the largest element. And if we want that 5 is at the right position, that it means the 5 should be greater than this element, because what happens in ascending order, all elements are always greater than its previous element. So it means it's going to be greater than or equal to last element. And if this element is not greater than, it means it is less than last element, then we simply return false. It means this element is on the wrong position, or we can say that this element is out of order. So the idea of efficient approach is simple. We have to traverse the array and check for all the elements that is out of order. Once we found that the element is out of order, we simply return false. So here is the implementation of efficient approach. Here we have a function. This function is taking array as input, and we are finding a length of array and storing it variable L. And then we are running loop from 1 to less than or equal to L. Why we are running from L? Because just now we did one observation that we are assuming that all the previous elements are already sorted. So here we are assuming that 0th element is already sorted. We do not have to check for 0th element, obviously, right? Then we are running loop from 1 to less than n. So inside this loop we are checking if ARR of I is less than or equal to ARR of I minus 1. So it means, let's say we have reached to this element 5. So this is our ith element. So we are checking if ith element is ith minus 1 element. So we are checking if ith element, it means 5, is less than or equal to ith minus 1 element. Ith minus 1 element is 4. If we found that this element is small, then we simply returns false. So if we never went into this condition, then after completing this loop, we are simply returning true. It means our array is sorted. So let's quickly try run this code and see how it works. Let's say we have an array of elements 2, 3, 0. In first iteration, we begin our loop from I equal to 1. At first position, we have 3. We check if 3 is less than or equal to 2, and it is not. So we continue to next iteration. Our I becomes 2 and element at index 2 is 0. We check if 0 is less than 3 or not, and this time it is. So we simply return false. So the output of this array is false. It means this array is not in sorted order. Okay, so far so clear. Now talking about the time complexity of this function. In worst case, this function takes big of n time. So in case you get this type of array, then you have to traverse array from first element to last element. So in worst case, the time complexity of this function is going to be big of n. But in worst case, maybe you get this array where the second element itself is in the out of order. So in the first iteration itself, you get that the array is not sorted. So you can find that in constant time. So we generally interested in finding worst case of an algorithm, means when n becomes larger than how our algorithm performs. So overall time complexity of this function is going to be big of n. And what about space complexity? We know that we are not using any extra space other than all the variables. So the space complexity of this function is going to be theta of 1. It means we are using constant space and big of n time to solve this problem efficiently. Okay, so far so clear. So before we end this video, let's have a quick recap of what we have done so far. So we are given an array and our task is to find whether an array is sorted or not, and specifically array is sorted in ascending order or not. And it is also possible that two numbers can be same. To solve this problem, we saw the brute force approach. And what we did in brute force approach, we select one number at a time and we check if we found any number less than equal to the selected number towards the right of it. And using this approach, the time complexity came out to be n square, big of n square. After a brute force approach, we saw the efficient approach to solve this problem. And in this approach, our observation was if 0th to I-1 elements are already sorted, then obviously the ith element is always greater than ith minus 1 element, right? Using this observation, we have solved this problem using this approach, and the time complexity came out to be big of n. So I hope now you have good understanding of how to find if array is sorted or not. So this is it for this video. Thanks for watching. See you in the next video.